For Chapter 15, it is about the nuclear magnetic resonance spectroscopy. So first, what is NMR? NMR, it is a nuclear magnetic resonance spectroscopy. It is the most powerful and broadly applicable technique for structure determination available to organic chemists. Indeed, the structure of compounds can often be determined using NMR spectroscopy alone. Although in practice, structural determination is generally accomplished through a combination of techniques that includes NMR and IR spectroscopy and also the mass spectroscopy. So the NMR spectroscopy it involves the study of interactions between electromagnetic radiations and the nuclei of atoms. So a nucleus with an odd numbers of protons and an odd numbers of neutrons possesses a quantum mechanical property called nuclear spin, and it can be proved by an NMR spectrometer. Consider the nucleus of a hydrogen atom, which consists of just one proton, therefore has a nuclear spin. Note that this property of spin does not refer to the actual rotations of the proton. Nevertheless, it is a useful analogy to consider. Now here in this picture the example of the axis of a sign and the magnetic moment. Also, makita po dali ang magnetic lines of force. So a spinning proton can be viewed as a rotating sphere of a large which generates a magnetic field and it is called magnetic moment. So kining magnetic moment mo ni siya ang spinning proton. It is similar to a magnetic field produced by a bar magnet. So here example sa left side nadira ang no magnetic field sa letter A, and then the right side diri na naka-applied ang magnetic field. So when the nucleus of hydrogen atoms or a proton is subjected to an external magnetic field, the interactions between the magnetic moment and the magnetic field just align either with a field or against the field. Again, the magnetic moment must align either with the field or against the field. So in this example, the energy gap between alpha and beta spin states as a result of an applied external magnetic field. So a proton aligned with the field is said to occupy the alpha spin state, while a proton aligned against the field is said to be occupied the beta spin state. The two spin states are not equivalent, and there is a quantifiable difference in energy between them. All protons do not absorb the same frequency because of the diamagnetism, a weak magnetic effect due to the motions of surrounding electrons that either shield or de-shield the protons. Now, when irradiated with radiation, the nucleus flips to a higher energy spin state and is said to be a resonance. A spinning proton generates a magnetic moment which must align either with or against an imposed external magnetic field protons. The nuclear magnetic resonance or the NMR spectroscopy provides information about how individual carbon and hydrogen atoms in a molecule are connected to each other. Deiodorated solvents containing a small amounts of TMS are generally used for acquiring NMR spectra. The range of frequencies required to achieve resonance is dependent on the strength of magnetic field, which determine the operating frequencies of the spectrometer. Continuous wave spectrometers have been replaced by FT-NMR spectrometers, in which the sample is irradiated with a short pulse that covers the entire range of relevant frequencies, and a free induction still is recorded and then converted into a spectrum. Now, the integration is often represented by step curves where a height of each step curve represents the area under the signal. Now, the integration or area under signals indicate the number of photons giving rise to the signal. These numbers provide the relative number or ratio of photons giving rise to each signals. Now, some quick informations. The replacement test is a simple technique for verifying the relationship between protons. If the replacement test produces diastereomers, then the protons are diastereotopic nucleus. If two protons are neither homotopic nor enantiotopic, then they are not chemically equivalent. When two protons are interchangeable by reflectional symmetry, the protons are said to be enantiotopic. Multiplicity represents the number of peaks in a signal. A singlet has one peak, then a doublet has two, a triplet has three, a quartet has four, the quintet has five. Multiplicity is the result of spin splitting, also called coupling, which follows the n plus 1 rule. The complex splitting occurs when a proton has two different kinds of neighbors, often producing a multiplet. Now, the equivalent protons do not split each other. Instead, in order for protons to split each other, they must be separated by no more than 3 sigma bonds. Now, when the signal splitting occurs, the distance between the individual peaks of the signals is called the coupling constant or the G value and is measured in Hertz. Now, generally, no splitting is observed across the oxygen atoms of an alcohol. It's because the hydroxyl protons are lapile.